Assalamualaikum and hello students. So today we continue our third subtopic, indices, surd and logarithm. Okay, first indices. So if A is a real number and n is a positive integer, then A to the power of n is equal to A times A times A, so n times. For example, we have A power 3. So means that equal to A times A times A. So 3 times. Okay. So the number A is called the base and n is called the index. So A power n can be read as A to the power of n. So the index of a number says how many times to use the number in a multiplication. Okay. So rule of indices. So we have 5 rules. So the first one, A to the power of n times A to the power of n. So when we multiply, so the power, which is the index m and n, we can add. So become A to the power of m plus n. And then the second rule, so A to the power of m divide A to the power of n. So when divided, so the index or the power of base A, which is m and n, can be subtracted. So equal to A power m minus n. So m must be greater than n. Okay, next. A to the power of m and then in bracket power n. So this one we can multiply the index. Okay. So become A to the power of m times n. And then also the fourth rule. So we have A times B in bracket power m. So we can split into 2 equal to A to the power of m times B to the power of m. And then another one, A divided by B in bracket power of m. So this one also we can split it into A to the power of m and then divide B to the power of m. So B cannot equal to 0. So denominator cannot be equal to 0. Okay. So this is the rules of indices. And then next, zero index. So this one from rule 2. So rule 2, this one example, A to the power of 4 divide A to the power of 4. So from rule 2, when we divide base, the same base, and then we divide, so the power or the index will be minus subtracted. Okay. So A to the power of 4 minus 4 equal to A power 0. Okay. Also by division, A to the power of 4, when we divide by A to the power of 4, we will get equal to 1. So we can conclude that A to the power of 0 is equal to 1. where a not equal to 0. Okay, so this one we call zero index. So any values that power 0 will equal to 1. Okay, next, negative index. So example, you have a power 2 and then divide a power 6. So from rule 2 also, so when base same base and then we do division, so the power will be subtracted. So the index, which is a power 2 minus 6, so equal to a power negative 4. And then by division, so a power 2 divided by a power 6. So you can simplify this one. So you will get 1 over a power 4. So therefore, we can conclude that a power negative 4 is equal to 1 over a power 4. So in general, a to the power of negative n equal to 1 over a power n. Okay, so this one is negative index. Okay, so rational index. So from rule 1, a to the power of 1 over 2 times a power 1 over 2. So same base a, so we can add the index. So equal to a power 1 over 2 plus 1 over 2. So equal to a power 1. So this means that a power 1 over 2 is equal to set a. So set a times set a, so equal to a power 1 or equal to a. So in general, a to the power of 1 over n equal to set a, and then n will be outside the set. Okay, another example, a to the power of 1 over 3 times a power 1 over 3 times a power 1 over 3. So same base a, so we can add other index. So equal to a power 1 over 3 plus 1 over 3 plus 1 over 3, so equal to a power 1. So we can conclude that a to the power of 1 over 3 is equal to set a, and then 3 will be the outside of the set. Also, we can write it as a to the power of m over n. So m will be the power of base a, so a m, and then n will be the value outside the set. Or we can also write it as this one. So set a and then n outside the set, and then in bracket power m. So m outside the bracket also can. Okay. Next, index property of equality. So for positive real number a such that a not equal to 1. So if we have a to the power x equal to a to the power of y, so same base a, so we can conclude that the index x is equal to y. Okay, so same base a, so equal, so we can compare the index. So x is equal to y. This property can be used to solve equation where the index is not known. Example, 2 to the power of 2x equal to 2. So we know that 2 power 1 is equal to 2. So same base 2. So we can compare the index. 2x is equal to 1. And then we can solve for x equal to 1 over 2. Okay.